All right, welcome back. So today the challenge is to design a web application, like a web server architecture, and pretty much document, the various components and what is necessary to have a redundant and functioning website. And I'm doing this from scratch, and I've never really done this before, so let's see how it goes. We're going to use Draw.io to design the architectural diagram, but AWS icons can get pretty crazy. There's like different versions of EC2, and a lot of things kind of look the same to some degree, but we'll see how things go. So here's Draw.io, and then page. No, I just want to add text. Do I double click? What about double click? Text. Hey. Okay. So I know we're gonna need EC2. Why? Because web server typically means that there has to be some kind of computing happening. Left justify. Okay, so that's EC2 compute, web server. Now, what else do we need? Can I make this bigger? Is that what that does? Nope, that's an arrow. Why is it like center justified? It's kind of weird. How do I make it stick to the top? Block. Alright, I'm getting sidetracked with the formatting, but EC2 compute web server. Okay, so maybe we'll forget about services for now. It's gonna get kind of crazy. We need compute, which means we need some kind of server that's going to host some kind of code. Okay, that's typically one thing. And then we also need a storage, right? And so what are we gonna store? Customer data. What else? Customer data. Okay, we're assuming it's like a web, like a website for a store. So like e-commerce, because like, do we really need resilience for like, just a blog? Like, so what if it goes down? No one really cares. But if it's an e-commerce app, it's like, okay, there's direct money and direct impact of downtime. So downtime is going to cause a loss of money, which we don't want to happen. So we need compute. Then we need storage. What else do we need? We need to manage traffic management. So that's kind of pointing towards like, load balancing. Let's look at this guy again. So front end, back end, database, storage, what kind of scaling we want to do. So for example, if we're talking about compute, then is compute too broad? Yeah, I guess there would be computer's typically backend, right? Like that's what's actually hosting things. But if you have like front end server, like web app, so this storage would be not for customer data. It would actually be for artifacts and objects. And then you have a database, and your database would be containing structured information that needs to be edited and updated. Now, you have traffic management, which pretty much includes load balancers. What else do we have? Front and backend, database and storage. Yeah, that's kind of the main. Identify which must be redundant. We can do that in the architectural diagram. Okay, furthermore, these are not really components, but there's privacy and security. So for example, for privacy, there's personally identifiable information, which needs protection. So we want to be careful. Security and privacy go hand in hand. So we're gonna need security groups, and we also want to probably implement our gateways in a logical way. I'm pretty overwhelmed by this because I don't feel very confident in what I'm doing right now, but I'm trying, so we'll see how that goes. So we have the AWS cloud. Now, the beautiful thing about the AWS cloud is that
Okay, so we're back. Um, so we had gone through phase one, which is component identification and scaling strategy, and we covered almost everything, and so we're just left with security groups and gateways. Now, I was having some issues with doing the just figuring out how this thing works, this UI for draw.io. Okay, looks like it's apps.diagrams.net now, but that's fine. So, right, so our EC2 instances can access our bucket, but the problem was that our buckets I don't know why I'm unable to access this auto scaling group. It's really annoying, actually. Unlock, like, is that? Oh, okay, so you can use like CAD logic. Yeah, I guess that makes sense. Okay, no, I don't know how I did that. Okay, I think I have to lock and then grab. Oh, just kidding, because it's locked now, so I can't move it. Okay, so we're back. Where were we? So we have almost everything. Oh yeah, we're figuring out security groups and gateways. So what we did is we struggled a lot with moving these security groups. Maybe I'll just make it even bigger. So these are in one security group. Yeah.
Okay, so basically our challenge was to move from conceptualization to documentation for a resilient web application infrastructure, specifically in AWS architecture. And we divided this into 3 phases. The first one is component identification and scaling strategy. Second one is architectural diagramming. Third is documentation and justification. I haven't gotten into that. I think I might write a Medium article about my experience. I've never done an architectural diagram before, so this was really challenging. But it was a very interesting learning experience. So the first thing we did is we identified what kind of components we're going to need. So in this case, we were dealing with a kind of open-ended front-end web application specifically for e-commerce. And so the components that I identified were we need a front-end server to actually host the web application so that people can access it from the internet, and we need back-end compute to process transactions, process customer states on the website and that kind of fun stuff. Basically host some more complex code and processes, and then we're going to have storage to hold any artifacts and objects that we need to run our website, a database to store customer data and structured information, probably in RDS, traffic management. So for example, if we need to scale and have scalability, then we also need to manage incoming traffic accordingly. And then privacy for customer information that might need protection. And lastly, security, so security groups and gateways. So now getting into the actual architecture. So what we have is we basically have here a somewhat serverless multi-AZ kind of like isolated architecture. So for example, we have incoming requests from our internet gateway. This is how people are going to access our website, and we're going to deliver our content to them via the CDN, CloudFront, which is a global service. S3 is also a global service, so we learned that these services are not within the bounds of our VPC because they're global services, and so they're not just sitting in any of our availability zones. They're distributed across the world, across AWS data centers. So when we have incoming requests, the incoming request is going to come to the internet gateway, and then it's going to go and hit CloudFront, and CloudFront is basically going to route those, it's going to route that traffic to our application load balancer. As a matter of fact, we can make a slight change here, which is that I don't want a line in here. So this is incoming traffic. So what's incoming is basically people can come and access our content from via this distribution network. And so this is a really cheap and efficient way to host a static front end website. And so we basically just drop our artifacts that our website needs to function in S3, and we can pipe that into CloudFront, which is going to deliver it as a static website. Now initially I was thinking about having EC2 servers within a public subnet, which you could do as well, but I think that would be a lot more expensive. It would add more complexity to the architecture, and also it might not be necessary. Although when it comes to hosting a website, in this case I thought, okay, like let's go with a very static and simple front-end architecture. But if we did do EC2, maybe that would be more appropriate for a dynamic front end. So maybe you have lots of, I don't know, like advertisements or changing product, or more fancy front end like Ruby, or I don't know, but you get the point. So if we had a really simple front end website, we would do it this way with S3 and CloudFront. But if we wanted to do a more dynamic server, then maybe it would make sense to put those EC2 instances in our public subnet. Now this is for incoming traffic. So our incoming traffic is going to hit our CDN, and our CDN is basically going to connect to our application load balancer, which is in a isolated security group on its own. Now this load balancer, technically it's across multiple subnets, and so I kind of put it in the middle here, and it's touching. It's not in one particular subnet, but it is connected to our two subnets within our multi-AZ infrastructure. And then our load balancer is basically going to take any kind of load that's coming from our front end hosting and, you know, send it to backend, whether that's transaction processing or things of that nature. And then also, I'm also going to make these just like that. Yeah, that makes sense. Okay, so we have incoming traffic and we also have outgoing traffic. So our EC2 instances in our private subnet, you know, they might need to get updated, they might need to be patched, and so we can use our router, basically our cloud router, which is a NAT gateway within our VPC, within our public subnet to access our internet gateway. Okay, I initially drew these NAT gateways connecting to CloudFront. I don't know if that is correct. Maybe they should go directly to the internet gateway. So there's definitely still some ambiguity, and like, you know, this is my first time designing this kind of architecture, so I'm not 100% sure, but you learn more every day, so it's not a big deal. Now moving into our next security group. So we have our EC2s in a private subnet. They're within a separate security group, which is the application security group. So for backend processing, we have these in one security group, and then we also have you know, this database. And so we have a RDS instance within both AZs, although I think it might be a good idea to also use a, I forget what it's called here. Why don't we ask Gemini, instead of doing RDS in two AZs, can I use a sync backup service? I remember there's some service in AWS where you can basically there's like a backup service, Aurora RDS read replica. I think it's that read replica, this guy. So, you know, we have redundancy, but it might make more sense to do it like this. I would imagine having a read replica would be cheaper. Yeah, so this is a high overview. We have our content delivery for our front end, our artifacts in our S3. We have an application load balancer spanning two public subnets. We have NAT gateways in each subnet to allow for our EC2 servers to be, like, you know, patched or updated or whatever. And our EC2s are isolated within their own security group. Oh, I forgot to mention that. So I put like a bunch of these just to kind of as a symbolic thing, but these are within an auto scaling group because we have one auto scaling group across two private subnets within separate availability zones, so that if our application load balancer is sending a lot of traffic and we need to scale up, then we can scale horizontally to meet that need. And then, yeah, any information that we need to like access in terms of customer data would be in our RDS, which is isolated as well in its own database security group. I'm not sure if this would have to access this RDS instance instead, But yeah, that's pretty much how far we got, and I'm pretty comfortable with this. In the sense that like I think that going deeper is kind of not useful at this stage. But yeah, so this is just kind of a demonstration of like how much I've learned about architecture, AWS, and how subnets interact, security groups, and information. So various gateways involved, like NAT gateways, internet gateways, and just some knowledge of basic services that can solve a simple problem, or maybe a not so simple problem, like starting an e-commerce architecture website. So yeah, that's it. Thanks so much for watching. If you got to this point, I doubt anyone will, but that's okay, because this is for me to not just just to document my findings and try to learn more and keep track of my progress. So peace out.